Hello, welcome back. Today we are going to start with chapter 3. So this video we're going to have two purposes. We have to describe the period, groups and blocks. Okay, so I think both period and groups is always mentioned in during your SPM time. So the block of the element is considered the new element for you in this topic. And then next we are going to deduce the position of elements. Okay, but this time this one also you quite often do in your SPM, but this time we have to base on the electronic configuration that you learned in chapter 2. Okay, let's recall the periodic table. As we already know, the element arranged in the periodic table in order of increasing proton number. There is 18 groups, 18 vertical column, so means 18 groups. Okay, element in the same group contain of same number of valence electron. Due to the same number of valence electrons, they are going to have same chemical properties. Okay, so a reminder at here, same valence electron is different from same number of valence electron. Okay, if for example, if I have 3 siblings, you also have 3 siblings. So I can say that both of us have same number of siblings, but I cannot say we have same sibling. So this is the difference between the same valence electron and also same number of valence electron. Your sibling is yours, my siblings is mine. Okay, so beside from the vertical column, there is another 7 horizontal row. Okay, so all these 7 horizontal row represent the number of shells occupied by electron. Okay, then at the same time, you will notice that this periodic table can classify into another 4-man group, which is S block element, and then we have P block element, followed by D block element, and lastly is the F block element. Okay, besides from this, how we determine the block of the element, we will depends on, for the block, we will depends on the last electron filled in which orbital. Let's say the last electron is filled in s orbital, so the element is considered as s block element. If the last electron is filled into the p block element, so we will consider the element is p block element. Okay, so later we'll go in details. Okay, besides that, the periodic table also can the element in the periodic table also can classify into metal, metalloid, and also non-metal. Okay, so this one I will not highlight here again anymore because you already learned during your SPM time. Okay, so I think I just made the summary for the block of element because this is new for you. So basically, just now we have mentioned that we have S, P, D, and F block element. However, when we answering the question, most of the question only focus on SPD elements only. Okay, so basically, S block element are referred to element in group 1 and group 2. Okay, so the electronic configuration always end with S1 or S2, means that the last electron will fill into the s orbital. So s orbital only can maximum fill 2 electrons, so that's why it's either referred to S1 or end with S2. Okay, so then followed by p block elements are considered as element in group 13 until group 10. So the electron configuration will end with P1 until P6. Okay, so because of we know that it is in group 13 until group 18, so basically it's the number of valence electrons plus 10. Okay, this one will go in later details. Okay, while for the D block element, they are referring to the element in group 3 up to group 12, which is referred to transition metal. Okay, so again, the last electron will be filled into the D block element, so it can be D1 until D10. Now, let's continue with how to deduce the position of element from its electronic configuration. I believe that you answer this kind of question during your SPM time, but last time your electronic configuration is in 2.8.3, for example, okay? But here the electronic configuration always give in the question always are in the SPDF notation. Okay, so still the same. Period is represent the number of the outermost shell occupied with the electron. Number of shells occupied by electron. Okay, while for the groups is the number of valence electrons. Okay, for the blocks, we are going to look at the last electron filled into the orbitals. Okay, let's look at the step given here. Look at the example 1. We are given the electron configuration for element Q and X. Okay, so then question asks us to identify group, period, and also block of element. Okay, so based on your notes, you are going to determine the number of valence electron configuration. Okay, however, I will be more prefer if you are using the start with the step 3 as the number 1. Okay, orbital that the last electron is filled. Okay, last electron is filled. Okay, so if now we look at here 1s2 up to 4s2, so we know that basically based on the alphabet principle, we are going to fill up 4s first, and then only we will fill up the electron in 3D. So because this one, the last electron is filled in the 3D orbital, so we consider this one as D block element. Okay, next I will look at the highest principal quantum number or highest n value. So from here we have 1, 2, 3, and 4. So 4 is the highest energy level, means that the number of, the period of the element is in period 4. Okay, then lastly, I will look at the valence electron. So if the valence electron, I will look at the outermost shell. Okay, so the outermost shell is 4s. Once there is 4s electron, then I will try to look at the left and right side. Is there any d and 3d orbital filled with electron? If yes, so I'm going to conclude 3d and 4s both electron in 3d and 4s total up 5 plus 2, which equal to 7. Okay, since in the beginning we already identified it is D block element, and then the range of the group number for D block element is 3 to 12. So that's why for this one, the group number for this element Q is group 7, period 4, and D block element. Next question, which is element X. Okay, so again, try to look at what is the last electron fill into which orbital. So it's very obvious here, it will fill into 2p. So that's why we know that this element X is p block element, and then there is n equal to 1 and n equal to 2 in this electronic configuration. So 2 is higher than 1, so we know that element X is in period 2. Okay, then we will look at 2p orbital. We have to add on with 2s orbital here. So 2 plus 5 plus 10. Okay, why we need 2 plus 10? Because this time we already have the idea. If the element is p block element, we have to plus 10. Okay, so 2 plus 5 plus 10. So the group number is group 17. Okay, now let's continue with the tutorial question. State the group, period, and block for each element above. Okay, so we go through one by one. Before we go through one by one, so again, try to recall back the step. So normally first, prefer to find out the block. So how we going to find out, identify the block, the last electron, okay? So we focus on the last electron, fill into the orbital. Then next second, we're going to determine the period at where we try to get the highest energy level, highest n value. And then lastly, we will going to determine the block by adding the total number of valence electron. Okay, look at question element A. So last electron is filled into the 3p orbital. So we know that the block is p block element, while the period will be considered as 3 third period. Okay, and then lastly the block. Okay, we will total up the outermost shell is n equal to 3, so we will total up all the electron in n equal to 3. At where is 2 plus 6? Okay, because of it is a p block element, so we need to add on another 10. So the block is the group is 18 group. Sorry, this is not block, but it's the group. So it's group 18. Okay, element B. Last electron is filled in 3D. So it is D block element, but the highest energy level is 4. Okay, when this is D block element, so we are going to total up the electron at D orbital and also S orbital. So means 5 plus 2 equal to 7. Okay, next element C. Last electron filled into the 4s. So the block is s electron. And then at the same time, 4 is the highest energy level. So period 4. And then number of electron in the s orbital is 2. So that's why this one is considered group, element C is considered in the group 2. Next, followed by the element D. The last electron is filled into the 3d orbital, and then the highest energy level is n equal to 4. The number of valence electron is 3 plus 2, so equal to 5. Since element D is D block element, so we no need to total up, no need to add on another 10. Okay, last is the element E. So when we look at here, the last electron filled into the 4p and 4p orbital. So the highest energy level is 4. So we will total up the valence electron, which is 2 plus 6. Because of it is p block element, again we need to plus 10. So the total number of valence electron is 18. So It is in group 18. Okay, let's continue with question number 2. This question now is given us the position, and then we are going to write out the electronic configuration. Okay, so the other way around. So period 3, for this one, we will focus on period 3. So if period 3, so I know that we will end up with the 3. Group 2 is S block element, so means that end up with S2. So previous orbital before, what are the orbital before 3s? So they are 2p. What are the orbital before 2p? 2s. Before 2s, 1s. So you have to keep in mind that all the orbital before 3s logically and theoretically should be fully filled. Because when all the lowest energy orbital is filled with electron, then only we are going to fill up with the electron into the higher energy orbital. So 1s maximum can have 2 electron. 2s also have 2 electron. 2p maximum have 6 electron. So this is the electron configuration for element F. Okay, while for the element G, again, we have group 15. So we know this one is P block element. So element in period 2. So it will be end up with 2s2, 2p. So we have to remember to minus 2. So 2p3. Okay, so before 2s, we have 1s. So 1s2, 2s2, 2p3. So now we try to use the configuration, electron configuration, to total up last electron filled into p block element. 2 plus 3 plus 10 equal to 15. Okay, so remember, if that you are given the element in p block element, so you have to use the group number minus 10 and then minus 2, then only you will have the idea how many electron is in the p orbital. Okay, next one is the H. Again, group 80 means that is p block element. So for this one, it will end up to 3s2, 3p. Okay, how many electron in the p orbital? Like just now we mentioned, we're going to use 18 minus 10 minus 2, which is equal to 6. So means that 3p orbital will fill up to 6 electron, and it is also logic because maximum electron in p orbital is 6 electron. What are the orbital before the 3s orbital? So we have 1s full with electron, 2s full with electron, 2p also full with electron. So this is the electron configuration for element H. Okay, good. Next, we continue with the element in element I. Element I, group 17, means that P block element, and with the period 3. Okay, so element I is end up with 3p also. Before 3p is 3s2. So this time we are going to use 17 minus 10 minus 2 again, which is equal to 5. So that's why here we are going to write 3s2, 3p, 5. What is in front here? 1s2, 2s2, 2p6. Okay, last element J, group 16. Again, we have the idea it is P block element and then end up with 4. So element J end with the 4p as well. So this time we're going to use 16 minus 10 minus 2 equal to 4. So will be 4p, 4. Before 4p is 4s. Sorry, before Before 4p should be 3d10. Before 3d10 is 4s2. And then before 4s2 is 3p6, 3s2, 2p6, 2s2, and 1s2. So these are the electron configuration for element J. Okay, next, write the electron configuration for F2 plus. So we have the idea F2 plus means that they are going to lose electron. So if going to lose electron means that we are going to remove electron from the outermost shell. So which is the outermost shell in F? 3s is the outermost shell, and then lose 2 electron means that both electrons are going to lose at the remove from the 3s orbital. So the electron configuration for F2 plus is 1s2 up to 2p6. Okay, next one is G3 negative means that gain 3 electron. So after gain 3 electron, 2p6 will become 2p3 will become 2p6. Okay, I negative gain 1 electron. So I negative gain 1 electron. 3p still have space, so we can fill one more electron because maximum is 6. So will become 3p6. Okay, while J2 negative means that going to gain 2 electron. So if we gain 2 electrons, 4p still have is the considered the lowest energy orbital, and then still have space for the electron. So how many electrons still can fill up in 4p orbital? Yes, it is 2 electrons still can add on, so it will become 4p6. Okay, so this is how we going to write the electron configuration for the atom and also ion when the position of the element are given. So question C, state the block for each element. We already go through here. So this is the answer for the question 2. Continue with question number 3. The cation K3 plus has the electron configuration argon and then followed by 3d10. So at here we have the idea that argon, the proton number for argon is 18. Okay, or generally we have the idea that it will be 1s2 up to 3p6. Okay, so what is the electronic configuration for element K? Just want to highlight here, K3 plus is different from K. K3 plus is ion, while K is the atom. So K3 plus is formed when 3 electrons are lost from the outermost shell. Okay, this is the concept that we learned in chapter 2. Once the electron is lost, or once the electron is removed, we always remove the electron from the outermost shell. So now we want to write the electron configuration for K. So you have to imagine, okay, what is the following shell, or what is the following outermost shell for the element K. If K3 plus end with 3d10s. So from here we have the idea that all the orbitals in the n equal to 3 are fully filled. So that's why we can continue with argon. Okay, and then 3d10. So after 3d10, then because it's already full, so means that the outermost shell is referred to n equal to 4. So if at n equal to 4, we are going to make sure 4s is fully filled first. So maximum s orbital can fix 2 electron. But here is mentioned is 3 electron are lost. So one more electron will be from the 4p. Okay, so this is the electron configuration for element K. Okay, B, we have to determine the group, period, and block for the element K. So a reminder again, if the question asks us to determine the position in periodic table, basically it is refer to the elements. Okay, it is not refer to the ion because elements are in the periodic table, not ion in the periodic table. Okay, so means that we are going to refer this K electronic configuration to get the position of element K. So as we discussed before, first normally we will prefer to determine block first. Okay, so what is the block? So last electron basically fill in the 4p. So means that this element K is p block element. And then what is the period? When we look at the highest energy level, 4 is the highest. So means that it is in period 4. And then what is the group of element K? Since it is in p block element, so we have to add 10. And then we total up the number of electrons in s orbital and also p orbital. So when I total up all these three numbers, it makes us know that the group is group 13. Question number 4. Write the formula of the ion. So remark again. Reminder, this question wants us to give the formula of the ion form for the element L, M, and N. So this time they given us the proton number, so we can write the electron configuration. So 17, if you still remember, that means that we can write out use the shorthand using the neon. So and then neon is up to 2p6 followed by 3s2, 3p5. Okay, and then 16 electron means that is neon, and then we have 3s2, 3p4. While for the N, so we are going to use argon, 18 electron. Argon is up to 3p6, so means that one more electron is 4s1. Okay, so when we want to write after we write the electron configuration, okay, this is step 1. So then we need to check whether this element tend to gain or lose electron. What is the purpose that the element want to gain or lose electron? Yes, to achieve the stable octet electron arrangement. So according to the L, so it's up to 3s2, 3p5. Basically, we already have the idea. It is group 17. So if element L is group 17, means that L tend to gain electron. Gain how many electron? Gain 1 electron to achieve stable octet electron arrangement. So L, the formula for the ion L will be L negative. So while the M is group 16, so we are going to gain, the M will going to gain 2 electron to achieve stable octet electron arrangement. While for the element N, we have only one valence electron because it is 4s1. So in this case, N tend to lose electron to form cation. So we'll form N+. So these are the answer for tutorial question 1 until question 4a, at which we focus on the position of position of element in the periodic table, or based on the periodic table, position of periodic table, we are able to write the electronic configuration. Okay, before we end this video, I will show. Okay, these are the final answer for question 1, question 2, question 3a, 3b, and also question 4a. So in next video, we are going to focus on the atomic radius. So thank you for watching. See you later.